Everyone, thanks for joining me on Last Minute Maths again. In this paper, we're going to do a full work through of the EDEXCEL November 2020 paper 1. That's a non-calculator and higher tier. And even though it says May, these papers were actually used in November that year. Now, on the screen somewhere, you're going to see references to my other videos, and those include other exam papers and also particular topics with worked examples and techniques, etc. So please do check those out. You'll also find timestamps and a full topic list for this paper in the description. I use each question as an opportunity to do a little bit of a revision on each relevant topic. So feel free, use those to jump around to whichever questions you're most interested in. I hope you find it useful. All right, so question number 1. Let's go into that straight away. This says it is an arithmetic series. All right, and I'm going to just change the color here. All right, so arithmetic series, okay. This means you are adding the same number each time. All right, so same difference, if you like, between terms. All right, so as you can see, each time going from 1 to 4 to 7 to 10, the difference is 3. So constant difference. So with this kind of arithmetic sequence, where you can identify the constant difference, the amount that you're adding each time, which remains the same, then it's going to be that number. So for example, the 3 times n, n being obviously the number of the term that you're interested in. And then you need a plus or minus another number to get it to be the exact sequence that's given. So that's where we get the 3n plus minus c, right? C being the constant. So use the first one, n equals 1. All right, put that into what we just suggested there, the 3n plus c. So 3 times 1 plus c equals 1, which is the first term. All right, so first term, and rearrange that and you get c equals minus 2. Fairly simple. So that means that the nth term is given by 3n minus 2. All right. Number 2, question number 2. You've got multiplication of mixed numbers. All right. And in order to actually carry out the multiplication, the first thing you have to do is to convert into improper fractions. All right. So quick reminder, to convert 2 1/3 into an improper fraction, you first take the denominator multiplied by the whole number, all right, and then add it to whatever the numerator is. All right. So that's 3 times 2 equals 6 plus the 1 that was in the original numerator, and then the whole thing remains over the original denominator, which is 3. All right. So 6 plus 1 over 3, 7/3. Okay. Using the same technique, the second fraction, we take 4 times 3 is 12, plus the 15, plus the 3, giving us 15, and over the original denominator 4, so 15 over 4. All right. And once you've got it in the improper fraction form, then it's a straightforward multiplication. All right. So 7/3 times 15 over 4 and multiply straight across. 7 times 15 is 105. 3 times 4, 12. 105 over 12. And now you need to turn it back into mixed numbers. All right. So 12 into 105 goes 8 times. All right. 8 12s, 96, etc. And you're left with a remainder of 9 over the 12. And the 9 12s, you just simplify down to 8 3/4, as shown in the question. Okay. Number 3. Okay, we have a selection of graphs A, B, C, and D. And the question says match up the graphs to the equations. All right. Now, in this, I'm going to just do, again, a quick bit of revision. All right. X cubed, this one here, I'm going to start with that one. All right. That will always be where x is negative on the left-hand side of the graph, y will be negative, because if you have a negative number and you cube it, that will give you a negative result. So we're going to be down here somewhere, and the positive side is positive, so it does that. All right. Therefore, having said that, okay, the minus x cubed, you need to interpret that as being minus of x cubed. All right. It doesn't mean minus x all cubed. It means minus of x cubed. All right, so x cubed first and then minus. This means that this one is simply a reflection of the x cubed curve. All right, flip it upside down. Okay, so that one is going to look like that. Okay, and I hope you're all familiar with the x squared. Right, a quadratic or parabola, and the one that perhaps needs a little discussion is 1 over x. All right, if it's 1 over x, I'm going to do just one corner. 1 over x means that as x gets bigger and bigger and bigger, so 1 divided by a bigger and bigger number, it's going to get a smaller and smaller result. So y is going to get small when x is large. Right, so as you go in that direction, y is going to be going down, okay, somewhere down there maybe. And when x is rather small, let's say x is 0.1, then 1 divided by 0.1 is going to be 10. So that's going to be a larger number, so up here. So that graph actually is going to look like this, all right? And if you were to extend it that way, there'd be a corresponding side on the negative side of it. So using that information, all right, we go back to the graphs, and you can see that graph A is obviously the 1 over x, all right? Graph B, according to what I showed you earlier on, is the opposite, so the vertical flip or reflection in the x-axis, if you like, of the x cubed graph. Graph C is your straightforward x cubed, and graph D is your x squared. All right. So that is where we got these answers from. So the answers are in that order, B, C, D, A, etc. All right. Only 2 marks, so they are expecting you to recognize the graphs without very much discussion on it. Right, number 4. Okay. What they're talking about is 4 triangles, and they want to know which ones are congruent. Congruent means identical, meaning you can fit one triangle on another and they will be absolutely identical to each other. All right. And in order to find congruent triangles, you either have to have, or you need to know that all 3 sides are equal, all right, are the same in both triangles, or that all 3 angles are equal. There are other conditions, but in this particular question, this is all you need. Now, just eliminate, whenever you have these things, first technique is eliminate the ones that it can't be, all right? So start with triangle B, okay? We have 2 sides, 10 and 8, and an angle in this one here of 45. We don't know what these other 2 angles are, right? Because we don't know the length of this side either. So can't say anything specific about that. We then have another triangle with, again, sides 8 and 10. Now they give us a different angle, 55, all right? Fine. But again, we don't know this, we don't know that, and we don't know that side. So nothing can be confirmed about either of those triangles in terms of their side lengths or all the angles. So it can't be that one or indeed that one. So even if you aren't sure of which ones it can or cannot be, if you can eliminate those two, you can guess that it must be the other two. Just to prove the point, in triangle A, right, we know two angles, right? That obviously means we know the third one, okay? 180 degrees for angles, degrees in a triangle. So 55, 45 is 100, therefore the other one must be 80, right? And then the length of the side, if you like, connecting the 55 and the 45 is 10. If we go across to triangle D now, then again we have a 45 and an 80 degree angle in there. That means the final one is 55. So on the face of it, we've got the same three angles there. And if we have the same three angles and one of the sides is of the same length as another triangle, they must be identical. All right. And again, we've got the 45 and the 55 connected by a 10 centimeter line. So the answer must be A and D. Okay. Right, number 5. Okay. Sean pays £10 for 24 chocolate bars and he sells all 24 for 50 pence each. Right, and we want the percentage profit. So 24 times, and I'm going to leave that in pounds, okay, 50 pence, so half a pound, is a £12 income. All right. His profit is the original amount taken away, so his income, £12, minus the original cost, which is 10, and that leaves a profit of £2. All right. The percentage profit is given by profit divided by the original cost times 100%. Okay. Just worked out that the profit is £2 and the original cost was 10. So 2 over 10 times 100%, that comes straightforward, is 20%. Right. So question 6. Now this one is an opportunity for a bit of revision. All right. We can see that we have two parallel lines, EB and DC. All right. And they've given you a couple of starting angles. So 63 here and 148 there. All right. Now, I'm going to just add a little detail there. When we have parallel lines, there are 3 rules. And for my students, I tend to label it as, for example, the C rule, the Z rule, and the F rule. Okay. This one is co-interior angles. Right, I'm just going to write the key word so you can hopefully remember it in short form. Co-interior angles add up to 180. All right, that's the first one. So the insides of that C shape, inside corners. Now the next one is the Z shape, and that is alternate. Alternate angles are equal. So basically the corners of the Z, all right, given that these straight horizontal lines are parallel. And the last one, the inside corners of the F, that is corresponding angles are also equal. Those are the 3 rules that you need to know for parallel lines, all right? So how can we use those? All right. I've written the answer down below, but I'll talk you through it. Now, in this particular triangle, right, there were 2 ways of approaching it, either using the parallel line rules or using the fact that it's similar triangles. All right. Okay. So using the corresponding angle rule, okay, we know that the 63 here must equal the 63 from AEB. So that one there, all right? Because it's like an inverted F. So if these lines are parallel, then this angle here will equal that angle there. All right. So that's what's used for that particular rule. So that's 63. On the right-hand side, we know that this angle here, 148, and this angle here that I've put in as 32, are on a straight line. All right. So straight line angles add up to 180. So all you have to do is to get the marks on this one is state that angle AEB equals 63 using corresponding angles, and then angle ABE, which is the 32, so that one there, and that comes from the rule that angles on a straight line add up to 180. All right. And now that we have the two angles in a triangle, AEB, that whole triangle there, a small one, we know that 63 and 32 add up to 95, and x must be 180 minus that. All right. And in order to get the full marks on this one, you put down all the angles, and then you must put the reasons. Okay. And it's always good to put in an actual calculation, even though it might be obvious and you can do it in your head, but put in the actual statement. All right. So angle EAB in the end is 180 minus the sum of the other two angles. All right. So 180 minus 95, and you get 85. All right. So put in all that detail, and that hopefully gets you the full marks on that. All right. Question number 7. You've got information about heights, okay, in centimeters of a group of year 9 girls. Okay, so you've got least height, you've got the median, and you've got the greatest height. All right. And then they give you a stem and leaf diagram, all right, for the heights of a similar group of 15 year 9 boys. Okay. And the number of students or whatever is actually irrelevant. Okay. So what we have here, the important part to note first is from the girls' data, all right, work out that the range is 170 minus 150, all right, is the tallest minus the shortest. Okay, so that equals 20, and the median we already have as 165. Okay. For the boys, exactly the same information that you need. Reading a stem and leaf diagram, remember the key is there. All stem and leaf diagrams, whether you're reading off them or you're asked to actually draw one, always remember to look at the key, and if you're drawing one, you've got to put the key down, otherwise you don't get the full marks. So in this one, we've got the smallest height, or lowest height, is 158 there, and the tallest is the 18 and the 2, so 182. All right, and that's what I've got here, 158 to 182. So the range in this case is the 182 minus the 158 equals 24. All right. Now the next thing we need to work out is the median. Now for this particular bit, the number of students is important because of the 15 boys, you want the one bang in the middle. Now remember, the median is the middle value when they are put all in order. All right, so it's got to be exactly the middle value, and that means it's got to have the same number of values above and below that value. All right, so the middle value. Right, so if it's 15, all right, then the middle one is going to be the 8th. Okay, so the 8th value has 7 above it and 7 below it. All right, and that turns out to be that one there. So it's 16, so 160, and 8, so 168. All right. Okay, now they're not actually asking you to write all that down, but it helps. And they're saying compare the distribution of the heights of the girls with the distribution of the heights of the boys. All right. In this type of question, you must use numbers, use numbers or data. Right? You can't just say the boys are generally taller or the girls are generally shorter, something like that. No, you've got to use numbers and data. Right? And the second thing, you must use a statement of comparison. All right? So I'll explain what that means. So my first point is that range for girls is 20 centimeters, and then boys have higher range of 24. So there's your numbers. And saying that the boys have a higher range, okay, that is a comparison of the two. Similarly, we're saying boys have higher median of 168 compared to median of girls, which is 165. So again, we're using a comparison and we're stating the numbers, all right? So that technique is very important. You've got to be specific and you've got to state which one is greater, which one is lower, etc. All right. So next question, number 8. All right. Now they've given a strange shaped prism. Turns out to be a hexagon and possibly not even of a regular shape. But anyway, they've put a formula on the right hand side. All right. So obviously you're going to need that, all right, in the question. So pay particular attention to that. Then they've given you some data. The prism is 3 meters tall, and the volume of the prism is 18 cubic meters. Right? Everything's in meters here. All right. Then they give you data on the pressure is 75 newtons per square meter. All right. So they're asking you to work out the force, all right, exerted by the prism on the floor. All right. So using the arrangement they've got there, if P equals force over area, so pressure is force over area, then multiply both sides by A, and you've got A times P equals the force. All right. So just a little rearrangement, and we get the force equals pressure times area. All right. We know the pressure. They've given us the pressure, but we don't know the area. Okay. So we're going to have to work out the area of the base of the prism before we can do the calculations. Now, we know that for a prism, the volume, and this is a formula that you're supposed to know. All right. Volume of a prism equals the area of the end face, right, times the height or length, whichever the case is. Again, rearranging that, right, area therefore must equal the volume divided by the height. Okay. And in this case, we've got the volume and we've got the height. Right? Volume is 18 and height is 3. So 18 divided by 3 is 6 meters squared. Right? 6 square meters is the best way to put it. That's the area. Right? Equals area. Now for the force, we know that we need pressure times area. So the pressure is 75 according to the question. And we've just found the area times 6. All right. And so the total is 450 newtons. All right. For those of you doing physics as well, there you go, newtons. That'll keep you happy. Right. Question number 9. Okay. Write these numbers in order of size. It says start with the smallest. So going from the smallest to the largest. And standard form. All right. These numbers are not strictly in standard form because they've used different types for each number. So starting with the first one, we've got 6.72 times 10 to the 5. Now that is proper standard form. Okay, so if you start with 6.72, and I'll do it fresh here, 6.72, and you got times 10 to the power 5, it means we're moving the decimal place 5 times, all right, which is exactly what I've done, all right, and that results in 672,000. Okay, the next one is 67.2 times 10 to the minus 4. When you have a negative power of 10, move the decimal place, right, to the left. This one moves to the right, right, because you're making the number bigger, and 10 to the minus 4, so 10 to the negative power, will make the number smaller, so you move the decimal place to the left, all right? So that one that way, and that one that way, all right? And that results in 0.00672, etc. The next one, 672 times 10 to the power 4. Again, the decimal place actually started here, and we moved it once, twice, 3 times, and 4 times. So this comes out to be 6,720,000. All right. So we can now see which one's which. So putting them in order, you've got the final one, the last one goes first. Okay. And then we've got the 10 to the minus 4, 67.2 times 10 to the minus 4, and so on. Fairly self-explanatory. Now, the important thing is you can write the numbers the same way that they've been written in the question, or indeed, you could write them out once you've converted them all into just normal numbers, right, without any powers of 10. Either form is acceptable to get the marks, all right, as long as you're consistent. Right, okay, that should be enough on that. Number 10, okay. They've given two fractions, ratios, if you like. A ratio of A to B is 2 to 5, and B to C equals 3 to 4. All right. So this is like a fraction version of ratios. All right. And the corresponding numbers, so in this case, I'll take the first one, A, and then on the other side, the fraction has a 2 on top, and the B has a 5. So it's connected that way. All right. So if we convert that, as you can see, into ratios, A to B, right, is therefore 2 to 5. What they're asking for is a ratio of A to B to C. All right. So using the second one, we've again got the 3/4. So you now see where that came from. Now, what's important, and I'm going to actually rub this thing out, all right, is that the common value, the common variable, if you like, in both of them is the B. All right. So that links the A and the C. All right. So what we want to do is to get the numbers for the B to be like a common number. All right. And in one of the ratios, B is in terms of 5. The other one, the B is in terms of 3. All right. So the best thing to do is make this common. Make B a common value. Okay. So the best thing to do is times the left-hand side by 3 and times everything on the right-hand side by 5. All right. What that does is makes B 15 in each case. So 15 and 15. All right. And obviously, if we're timesing the left-hand side by 3, then the A gets times by 3 as well. So that'll be 2 times 3, 6. And we know the B is 15 in both, so that's fine. And the C gets times by 5 as well, so that's 20. So there's your ratio, 6 to 15 to 20. Whenever you get these questions with 2 or 3 variables and they want you to sort of like link different ratios, make one of them common. The one that appears in both of them, make them common, like we have done here. All right, number 11. Okay, this one, is using simply roots, okay, powers and roots. And there is another video. I've got a video on powers, roots. It's in the playlist, I think, as laws of indices. That's the formal term for it. So if this kind of question is a little confusing, then please feel free to check out that video, and that has some revision material for all the different types and perhaps more complex powers as well. All right, how are we going to do this thing? When we take the fourth root, notice this thing has the fourth root, all right, like that. That's the same as something to the power 1/4, all right, just as a quick revision. But there's an easier way of thinking of it, all right? If you square root something twice, so you square root a number, and then whatever that result is, you square root it again, then you are getting the fourth root of a number, all right? So fourth root is square root and then square root again, all right? So that's how we're going to approach it. I think that's a simpler version of doing this. So the square root of 81 to the power, 81 times 10 to the power 8, you can split that up. And by the way, that also applies to rules of Surds, all right? That's two topics rolled into one in this question. So split that up, and it's root 81 times square root of 10 to the power 8, all right? Root 81 we know is straightforward 9. And the square root of 10 to the 8, all right, that can be written as 10 to the, 10 to the 8 all to the power half. And when we have something like that, we multiply the power. So that actually comes out to be 10 to the power 4, all right? That's what we have there. We now want to square root that result all over again. So that's where we get this thing from, okay? So again, same technique, split it up. Square root of 9 is 3. And then the square root of 10 to the power 4 is going to be 10 to the power 2. So 3 times 10 to the 2 is 300. All right. Part B of that question, it says find the value of 64 to the power minus half. All right. A negative power means you flip the number upside down. It actually means reciprocal. Before I get people leaving comments about me making up rules, it's called the reciprocal, all right? So in other words, if I have 2 to the power 1, it means 1 over 2. If I have, for example, 3/4 to the power 1, right, or any negative power, you flip it upside down first before applying the power, all right? And that is 4/3, all right? Please don't make the common mistake where 2 to the power minus 1, right, gives you some sort of a negative number. No, it doesn't. Okay, all it means is flip the number upside down or put 1 over it, that sort of thing. Okay, so what we're doing, the first thing, I'm going to apply the negative power, all right? So the negative power there, and I'm going to put 1 over 64, and then I'm going to apply the half, power half, and half is effectively a square root, all right? So that whole thing boils down to the square root of 1 over 64, and the root of 64 is 8. So there you have your answer, 1/8, all right? Okay. This next part is actually perhaps a little more complicated. They want you to simplify this sort of algebraic fraction, which has powers in it, as a power of 3. So we're going to express everything as a power of 3. 3 to the n is already a power of 3, so leave that alone. But 9 equals 3 squared, all right? So we're going to write 9 as 3 squared, and then apply the original n minus 1 power to that, okay? So that turns out to be 3 to the power n, divided by 2n minus 2, because when you have that, as I showed just earlier in the question, you're effectively multiplying those powers. So 2 times n minus 1, and that gives you 2n minus 2. When we divide, right, equals subtract the powers, all right? And that means that effectively all of that is 3 to the power n minus 2n minus 2, okay? Now, be careful with this one. The minus on the outside and the minus on the inside, you've got to make sure you apply that correctly, all right? So effectively this is n minus 2n, but then it's n minus minus 2, so it's plus 2, and that's where we get the 2 minus n. So the final answer is the whole thing simplifies to 3 to the power 2 minus n, all right? Okay, number 12, all right? They've got 80 people in some sort of a table of data, all right? Weekly wages, all right? And they've given the frequency for each category. So, for example, weekly wages of 200 to up to 250, all right? There are 5 people earning that much. Then 250 to 300, you've got 10 people, etc. So you've got the frequency for each category. What they want is a cumulative frequency. Cumulative means total up to the end of the bracket that you want, up to the max value of each class. And these are your classes, all right? So the first one is 200 to 250. So there are 5 people earning up to 250, all right? Then when you talk about how many people earn between 200 and 300, all right, you've obviously got the 5 who earn between 200 and 250, and then you've got the 10 who earn between 250 and 300. So that effectively is 5 of the previous and then 10 of this particular class, hence 15. And so basically you just keep adding as you go along. So the next one, you can see it's 20. Oops, hang on. 20. So we have the 15, add 20. So here, look. And this one plus 20. This one plus 20 again. This one plus 15. And finally plus 10. So that's how they get added on each time. All right, that gives you a cumulative. So in our data table, all 80 people earn between 200 and 500. Okay, that's what a cumulative table means. All right, that's fairly simple. And they're asking then, it says on a grid opposite, so there's a graph below this question, draw a cumulative frequency graph for your completed table. All right, so I'll skip back to the values when we need to. All right, so here's the graph that we need to work with. Okay, and I want to squeeze that down a bit so you can see the whole thing. All right, so what we've done is, if you remind yourselves, the value from between 200 and 250, there were 5 people. All right, so that's where that 5 came from. All right, now really important, plot the crosses at the end of the category. All right, so in other words, at the 250. All right, and similarly, the next one is at 300. Okay, because it's a cumulative. All right, and the next one is 350, etc. All right, not in the middle of the class, like 225 or 275. It's got to be at the end of the class for cumulative, all right? And just plot them all the way along. You can see the crosses on the graph there. And then with a sharp pencil, try and draw a smooth line, okay? Has to be smooth line or curve, if you like. And connecting all the points. And the other bit is that it has to go through 0. Through the 0 frequency value, if you like. All right, okay. That bit's important. And so you see what that's called. Often in the stats business, people call this the S-curve. Just a point of curiosity for you. All right, the next part of the question, once you've done that graph, okay, and now I'll go back to the size there. It states that Juan says 60% of this group of people have a weekly wage of 360 or less. All right. So what we want to do to find out if he is correct or not, okay, is look at where the 360 appears on the graph. All right. So the 360 actually comes in here. All right. So if you start at 360, hit the graph, right, at that point, and you read off the frequency, cumulative frequency, it's actually 40, all right? So using that data, right, 60% of 80, right, is 0.6 times 8, so that would have been 48 people, all right? But it's not. It's actually only 40 people. So the answer to the question is no, right? 40 people, and you've got to explain it, right? You must show how you get your answer, right? So please put as much detail as you want down. 40 people earn 360 or less, okay? The 40 over the 80 represents 50%. This is less than 60%, therefore the answer is no, all right? You've got to put all that detail in for the 3 marks that they offer, all right? Okay, I hope that's made enough sense. Moving on to question 13, all right? This one is actually a bit more involved. Takes a bit of thinking through, all right? They've got liquid A and liquid B. They're going to be mixed to make liquid C, all right? Now, they're given some information about A and some information about B, okay? But not the same information, okay? Both of them give us density, right? But one of them gives us mass, the other gives us volume, all right? And you are expected to remember that density equals mass divided by volume. So that there. Okay. And if you're not sure, right, the hint is actually in the question. Look at this. Density of 70 kilograms per cubic meter. So that actually gives you a hint that it is mass over volume. All right. So somewhere on the page, for your own sort of like help, write down D and MV in that order, the triangles that you used to see in GCSE maybe. From that, we can deduce that volume must equal mass over density, all right? So that we can use that form as well. Okay, now the next step is they want us to work out the density of liquid C, all right? Liquid C, the overall density, is going to be the total mass, all right, of liquid C over the total volume, all right? So in order to get the total mass and the total volume, we're going to have to add up all the bits of A and B to get that information, okay? Now, one of them, we are given the mass, the other one we're given the volume. So for each of A and B, we're going to have to work out the other quantity that's not given. Okay, so in the case of A, we need to find the volume. All right, so volume of A, using the formula there, is going to be your mass divided by the density. All right, so that's 1400 divided by 70, and I hope your non-calculator maths is good enough. That's the same as 140 over 7, all right, and that's 20 cubic meters. For liquid B, right, we're given the volume but not the mass. So in this case, we need the mass, all right? So the mass, using, again, the formula up there, is volume times density, all right? So we've got the volume, 30, times the density, all right? And so 30 times 280, you're welcome to do a long multiplication on that. Whoops, hang on a second. 280 times 30, 2 zeros already, all right? And then 3 times 28 comes out to be 84. Like that, nice and simple. All right, show your workings if in any doubt at all. So that gives me a total mass for B, all right? We can now construct the overall density formula that we need, that the total mass is the 1400 of liquid A plus the 8400 of liquid B. So that's A, that's B. And the same for the volumes, A and B. And we get total values of 9,800 kilograms for the mass, all right, there, and 50 cubic meters for the total volume, all right? And again, when you do the division, it's the way I've done is cancel the zeros. 5 into 9 goes once, all right? Left over is 4. Carried over, that is 5 into 48 goes 9. And you're left with, what have you got? 5 and 45, 3, and so 6, all right? That's the way to do the more, I don't know, I wouldn't say complex, but slightly longer division. Just leave it as a fraction and cancel top and bottom as you go along, divide each number, and you end up with 196, all right? Remember, no calculator. So this sort of thing, practice a bit more if you need to. Okay, question number 14, all right? This one is actually far more many words than perhaps you need to worry about. It sounds more complicated than it actually is, all right? Simple thing, 2 games, okay? And there are outcomes, win, draw, or lose, all right? In each game, they give you 2 of the probabilities first. So the probability Sally will win is 0.3. Draw is 0.1. All right? Okay. They don't give you what the probability of losing is. All right? So the first thing we're going to do is work out the probability of lose, that she loses a game. All right? Remember, if there are 3 outcomes, all right, win plus draw plus loss must add up to a probability of 1. All right? That must be the total. There are no other options, so those 3 must add up to 1. So in this case, the probability of losing a game must be 1 minus the total probability of winning and drawing. All right? So L equals 1 minus W minus D. All right? That's exactly what we've done. 0.3 plus 0.1 is 0.4. And so 1 minus 0.4, you've got your 0.6. All right. Now, the way that we can, Sally will win exactly one of the 2 games. All right. Well, if it's exactly one, then you can either win, right, and then lose, or win and then draw, right? So it's like this option, win, lose, or win, draw, or lose and win, or draw and win. All right, 4. These are, as I said, ors. All right, but in terms of the games, one after another, if you win one and then you lose, draw, whatever, the next one, right, you are multiplying, and that's an and, all right? So for this bottom one here, it's I've drawn one and I've won one, right? So draw and win, you have to multiply, okay? And or is when you have to add, okay? That's add the combination, and this is times, whoops. All right, so the first one, 0.3 times 0.6, 0.18. All right, remember the decimal places. Don't make silly mistakes with the decimal places. 0.1 times 0.1, 0.03, right, 2 decimal places, and so on. That's repeated again, right? So you got those. Add them all up, and 0.42 is your final answer. All right, so be methodical with these questions. All right, there's a lot of words in there, but that's all the information you need, are the probabilities, and read the question carefully. All right, number 15, you got straight line, L1 has equation y equals 3x minus 4, all right? L2 is perpendicular to L1 and passes through a specific point, okay? The rule that you need to remember for perpendicular gradients, right? M1, for line 1, that is gradient of line 1, times M2 must equal minus 1, right? So basically, what that translates to is that, let's say, the perpendicular gradient of 1 is minus 1 over the first gradient, all right? So in this case, my first gradient is m equals 3, because remember, y equals mx plus c, and m is the gradient, okay? So m equals 3, therefore the perpendicular one will be minus 1 over 3, all right? That's where we're getting the minus 1/3 from. Okay, so now the second step is that line 2 has equation y equals minus 1/3 x plus c, all right? Okay, how do we find c? And we'll just write this here. To find c, right, substitute in coordinates of a point, and any point really, that the line passes through. Which in this question they've given us is 9, 5. Okay? Those are the 2 rules that you need to remember for this type of question, and also a useful bit of revision there. So, all right, we're going to use the point 9, 5. So y equals 5 when x equals 9. So 5 equals minus 1/3 times 9 plus c. So that's 5 equals minus 3 plus c. C equals 8. So the equation of the line is y equals minus x over 3 plus 8. And before I confuse you guys, that is exactly the same as writing minus 1/3 x plus 8. All right? Same thing. All right. Next question, number 16. All right. Shirley wants to find an estimate for the number of bees in a hive. Okay. She catches 90 bees one day and marks each of those bees and returns them to the hive. All right. On Tuesday, catches 120 bees. Okay, and she finds that 20 of these have been marked. Okay, we assume the marked bees are spread evenly through the population, through all the bees there. So through the hive. All right. So on the second day, of the 120, only 20 are of the marked kind. All right. So that means that they form 1/6 of the population. All right. So 1/6 of the hive. And so 1/6 of the total must equal 90. All right. Think through that question just a bit, make sure you're okay with it. So that means that, when you spread them out, if 20 marked bees out of 120, all right, is your sample, then those 90 bees must be 1/6 of the total. All right. So if you write 90 is 1/6 of the total, like that, multiply the 6 across, so the total equals 6 times 90, 540. All right. If there's any confusion over that, leave it in the comments, and I'll be happy to perhaps do a separate couple of minute video just to explain that if you need. All right. Then it says, assumes that none of the marked bees has rubbed off. Okay. If Shirley's assumption is wrong, in other words, if some of the marks on the bees had been rubbed off, explain what effect this would have on your answer to part A. Okay. What happens is that, imagine of the 120 bees, we're actually counting 20, all right? But what if some of the marks had actually rubbed off? So it could have been, for example, let's see, what number shall we use for this? 24, let's say, all right? For example. All right. So we've effectively lost 4, all right? And that means that the actual proportion would have been bigger, not 1/6, but actually bigger. So in effect, if some of the marks had dropped off or been rubbed off, right, the total number calculated would be more than the actual total. In other words, it would have been a smaller figure. So for example, let me show you. If it had been, so 90 equals 24 over 120 times total, etc. So what's that then? 2 over 10, so 1/5. So therefore total would have been 5 times 90. There we are. All right. So in other words, that if you've lost any marks, our 540 therefore is counting too many. All right. It's overcounting the number. All right. I hope that makes sense. Right, number 17. Straightforward algebra, and I'm going to run through this as quick as I can. All right. First of all, you want to multiply the f minus 4 across there. All right, because the thing is to make f the subject of the formula. So we've got d times brackets f minus 4 equals 3 times brackets 1 minus f. Expand all the brackets. All right. Okay. So we have df minus 4d equals 3 minus 3f. All right. Now you want to get all the like terms together. So collect like terms. Okay. So df plus 3f, so minus 3f comes across as a plus 3f. the minus 4d goes across the other side as a plus 4d. And the next step you're going to do is to factorize the f from the two terms on the left-hand side. So factorize, and you've got f times brackets d plus 3 equals 3 plus 4d. So you want to, because it's a times here, take it to the other side, the d plus 3 as a whole item, and divide the other side by that. So you now have f equals 3 plus 4d divided by d plus 3, okay? And I've chosen to write it as f equals 3 plus 4d divided by 3 plus d. You can do it the other way around, 4d plus 3, d plus 3 on the denominator. It makes no difference. The terms are all correct. All right then, number 18. Now this one takes a little thinking, I think. What it's saying is that x is proportional to square root of y, right? So that's your original x, whatever it might be, okay? We then have another x value, all right? So I've put a little 2 next to it. So we've got another x value, which is some factor of, so let's say a proportion of 1.44y, because 44%, remember, is if you're increasing something. So increasing means 100% plus 44%, so 144%, and that as a decimal is 1.44. All right, so the second x value comes from 1.44 times the original y, so y is increased by 44%, so 1.44. And we can now split out exactly the same thing with surds again. All right. So we can do square root of 1.44 times the square root of y. All right. Now, you may not know the square root of 1.44 straight away, but you know that the square root of 144 is 12. All right. Let me write that more clearly, actually. Okay, is 12. So just to apply the decimal place there, right? Try 1.2 times 1.2, and you come up with 1.44. So therefore, the square root of 1.44 is 1.2, and then the original square root of y that we had. Therefore, this x2, the second x value, is 1.2 times the original. Now, using my percentage to decimal calculation backwards, the 1.2 is the same as 120%. So therefore, the increase is effectively, let's put this, 120 minus 100 equals 20. All right. The increase is 20%. All right. So I hope that particular one has made sense. Right. Number 19. Right. Functions f and g are given. All right. And they want, first thing, part A, g of 5. So effectively, wherever you see x in a function, i.e. in this function g, replace it with a 5, okay? So what we've done, g of 5 is 3 brackets, 2 times x, so x is replaced with 5, 2 times 5, which is 11, and then plus, oh, my apologies, 10 plus 1, and that gives you 11, and you got the 3 times on the outside, so 33, all right? The next one is g f of 9, right? G f of 9. Actually, you know what? I'm not going to bother writing that. Don't need it. I think it's self-explanatory. I'll use this. First, you do the inside one, right? The one closest to the bracket. So f of 9. Then you apply the g. So whatever the result of f of 9, put that into the function g, all right? Work away from the brackets, so work from the inside outwards to the g. I hope that makes sense, all right? So it's going to be g and the result of f of 9. All right. So first thing, over here, we've done f of 9. Remember, f of x is 12 over root x. All right. So in this case, 12 divided by root 9. So x equals 9. All right. So root 9, assume 3. All right. 12 over 3 equals 4. So that is the result of f of 9. All right. Take the 4 and put that into g now. All right. Exactly the same as we did before. We do 2 times 4, 8 plus 1. So that whole thing becomes 9. All right. And 3 times 9 is 27. All right. I hope that has been clear enough. Now, this next one. Finding the inverse. Before we can do the inverse, so this is inverse g of 6. All right. So inverse function of g. The way to do this, all right, is start off obviously with your function. We need to find the inverse first. And I'm going to let y equal the function. All right. So let g of x be y. So y equals 3 times 2x plus 1. And it's a question of now making x the subject. All right. So divide both sides by 3. Y over 3 equals 2x plus 1. Move the minus 1 to the other side. Okay. So y over 3 minus 1. Okay. And that equals 2x. And finally, we want to divide everything by 2. All right. So you can do it different ways. I could have written it like this. All right. And then divide that by 2. So you get y minus 3 over 6 equals x. That's exactly the same thing. All right. Doesn't matter which way you do it. Okay. So now that we know what the inverse is, we've got x whatever. Swap x and y. All right. And so we get effectively x becomes the y. So y equals x over 6 minus 1 over 2. Some schools in the classroom, what they ask you to do is to change it right at the beginning. So put x there and y here, and then make y the subject. All right. You'll end up with the same result. Okay. So whichever method you prefer, it makes no difference. Now that we have our inverse function, okay, we simply put 6 into it. So x is replaced with a 6. You've got 6 divided by 6 equals 1. Minus half is a half. All right. That's actually a lot of working for only 2 marks. So beware, you've got to be time efficient on that one. Okay. Surds question. All right. And this one, the main thing, again, this is in one of my videos, is rationalize or rationalizing the denominator. Okay. First thing we're going to do, we've got this great big surd fraction, all right, and we want to simplify it to that form there as in the question. All right. So let's start working our way through and simplifying each of those surds. First thing is square root of 180. All right. Factors of 180. If you just do a little scrummaging in your head, you'll find that you want a square number times root of 5, let's say, in this particular question, because everything's in terms of root 5. Turns out to be square root of 36 times 5. Okay. Square root of 36, take it out, is 6, and you're left with the root 5. So 6 root 5. All right. So using that, we've gone from there to there, and replacing the root 180 with 6 root 5 minus 2 root 5, and leaving the denominator as it was. All right. And in this case, we get 6 root 5 minus 2 root 5 is 4 root 5, and divided by 5 root 5 minus 5. This whole thing is a real mouthful, but try and I'll try and keep it as clear as I can. Okay. Next thing we need to do is rationalize the denominator, because we have a square root in the denominator, all right? And we don't want that. The thing is, multiply by the same two terms times top and bottom, okay, by same expression, but, that's the important thing, all right, but with reversed sign. Reverse the sign, okay? And I'm just going to add a little bit here. This rule comes from difference of squares. Just a bit of quick revision. So a plus b times a minus b is a squared minus b squared, all right? That's the result we're looking for, okay? So you've got to have the same two terms, but with different signs in between. That's what you want to multiply by. So multiply top and bottom by 5 plus root 5, okay? And I'm not going to labor the point. I think most of you can multiply across. 4 times 5, 20. 4 times root 5 is just 4 root 5. Underneath it, using the difference of squares rule here, all right, I've got effectively the same as a squared minus b squared, all right? And so 5 squared is fine. But remember, root 5 squared equals 5, all right? So that's what we have here, okay? Root 5 times root 5 gives me just 5, and the sign in between is minus. So the whole thing simplifies to 20 plus 4 root 5, all divided by 20, because that's 25 minus 5. And when you simplify that fraction, right, on the first one, you've got 20 divided by 20, which is 1. And then the second bit is 4 root 5 over 20. 4 over 20 is root 5 over 5. All right, that's where we get that answer from. Okay, so yeah, that's enough said on that one. All right, 21. DEF is a triangle, and what it's saying is that P and Q are midpoints, all right? So A is the vector going from F to D, like that, and F to E is the vector B, all right? And P and Q are midpoints on each of those sides, as you can see in the diagram. So I'm not going to describe the diagram, it's there, all right? And they're saying use a vector method to prove that PQ, all right, which is that line there, is parallel to FE, all right? And for two things to be parallel, parallel vectors have the same ratio of, what do you want to call it, components, right? Or the bits inside the vector. Okay. For example, 2a plus b, and I don't know, let's make it 6a plus 3b, all right? Those are parallel, for example, because the ratio of a to b is the same in both cases, all right? Okay, so what are we going to do? We want to find the vector p to q, all right? And we're going to go around the triangle to do that. So the vector pq, we can take a root that goes P to D and then D to Q. All right. So PD plus DQ. All right. PD, all right, is half of A. Straightforward, half of A. And DE, on the other hand, i.e. DQ, is half of DE. So that's what I've written here. PD is half of FD and DQ is half of DE. We know, as I've already said, that P to D, right, is simply half A because P is a midpoint, right? And then DE, right, this is a bit where we have to think about what we're doing. We don't know an exact vector for DE, so we're going to go D to F, F to E, right? So that's D, that's what I've done here. Look, DE is DF plus FE, right? And that will give you minus B, D to F, plus B, sorry, minus A plus B, right? That vector there, all right? Substitute that back in, all right? And when you expand the brackets out, you've got half A plus half B minus half A, all right? Equals half B. That, right, is exactly the same as half of FE. So it's the same, one vector can be expressed just as a multiple of the other vector, and therefore they must be parallel. All right, that's the proof. All right, I'm going to speed this up a little now, try and get this paper done quickly. It's a more complex paper than usual, this one. Okay, you've got two shapes. One is a sector, and one is a simple circle. All right, and they've given the radii of the sectors here, and you can see this, they've told you that the total radius of the sector is 5x minus 1, and then the individual parts are given to us as well. All right, and right, what are we going to do here? Okay. Oh, one thing before we jump into the question. Remember that this, they've given of this circle, is a diameter. Okay, so make sure you halve it to get the radius. And therefore the area, B, all right, in all of these cases is pi r squared. All right, bear that one in mind. Okay, so we need to solve for x by equating the area A and the area B. The area A, we know, is going to be the difference, right? So if you take away the small area, right, find the big sector minus the small sector equals area A, all right? So we're going to apply the two different sector sizes, the radius. The other thing they need to watch out for, remember that the area of a sector equals the angle at the center, right? Call it x degrees, divided by 360 times pi r squared, all right? This is effectively the fraction of the circle. Of a circle, represented by the angle at the center of the sector, all right? Okay, so what we have, the area of the large sector is 45, you got the 45 degrees there, 45 over 360, okay, there, times pi r squared. R squared in this case is 5x minus 1 all squared, because that's the radius of the big sector. And take away from that 45 over 360 again, because it's on the same angle, times pi times 3x minus 1 all squared. All right. So this whole thing, I'm going to jump and simplify a little, because 45 over 360 is the same as 1/8. So 45 over 360 over 1/8, right? And there's a pi that's common to both of them, there and there, all right? So I'm going to factorize all of that external stuff out. So the 45 over 360 times pi in both of them, factorizing it out as just pi divided by 8, and then leave everything else inside the brackets, all right? So 5x minus 1 all squared minus 3x minus 1 all squared. And then what we have here is expanding the brackets out. Now, I'm going to assume that you know how to expand brackets, all right? 25x squared minus 10x plus 1. That's from the first one. Now, the second one, all right, I'm just going to show you what's going on here. It's 9x squared minus 6x plus 1, all right? But you've got a minus on the outside there. So the minus 9x squared is fine. Then minus 6x plus 6x, and minus plus 1 is minus 1, all right? When you do all of that, you simplify it down, it comes to 16x squared minus 4x. Take out a factor of 4, you're left with pi over 2 times 4x squared minus x. You can take the x out, as I have done there, pi x over 2 times 4x minus 1. That's one way of doing it. Or you can leave the x in there, all right? Doesn't matter which way around you do it. So a equals b, and so we know that this is a. B is what I've written at the top of the page here, right? Pi times 1 minus x squared, 1 minus x all squared, and so that's b. All right. So tidying all that up, expand this thing, all right? Having cancelled the pi's out, because there's a pi on both sides, get rid of it. Expand the brackets on the right-hand side, 1 minus 2x plus x squared, all right? This 2, denominator, multiply across there. So you've got 4x squared minus x on the left-hand side, and this side you've got 2 minus 4x plus 2x squared, all right? Collect everything on the left-hand side. 2x squared plus 3x minus 2 equals 0, all right? So standard quadratic. And factorizing. Again, I've got a factorization video if you need to revise that. All right. And the two solutions from there are x equals half and x equals minus 2. Well, we can't have x equals minus 2, so x has to be a half. All right. Okay. Last one. Okay. This is an astonishing question. All right. All of that information, all of this, and different types of cards and shapes and colors and whatever, right? It's almost a joke, this question, and it's what, 3 marks, okay? All they're saying, after all that, right, cards with a black shape as a fraction of the total number of cards with a triangle, okay, all right? So the total number of cards with a triangle is, if you put it into fractions, black versus white, because it's a ratio of 3 to 5, 3 to 5, right? Then that's 3/8 and 5/8, because 3 plus 5 equals 8, and this one equals 9 total, right? And similarly, circle versus triangle is 2/9 versus 7/9. So again, ratio of 2 to 7, okay? So all we want, this whole sentence at the end there, all it means is that we want the black shapes as a fraction of total number of cards with a triangle. Okay, that's this thing here. Okay, so all we want is 3/8 divided by 7/9. All right, and that's written there. You remember that when you divide fractions, you flip the second fraction and you change the sign to a times. All right, that's all we've done here. Okay, 3 times 9, 27, and 8 times 7, 56. There we go, done. All right, so it's not as complicated a question as it first might appear. All right, if you've survived watching this one is a little longer than the usual videos. Thank you very much for watching if you've survived that long. Do please check out my other videos with the other papers and the various topics in both maths and science, actually. And if you found it useful or you find any other videos useful, then please do consider subscribing, leave a comment by all means, and click the like button. All right. And if you have any interest in particular topics or papers, then you're very welcome to leave a request in the comments and I'll be happy to do a video for you. Thanks for watching.